Howdy, howdy, howdy. We are talking fractions and we are comparing fractions. And what does it mean to compare? Well, we're looking for what is greater than, less than, or equal to. Okay, so how the heck do we do that with fractions? Well, firstly, let's look at a pair of fractions. We're going to have 1/2 and 1/3. Now, we can probably already tell which one's greater than. From what we've learned about fractions, the smaller the denominator, that means the bigger each piece of the pie, right? So we don't really have to do much work on this one. We know that 1/2 is greater than 1/3, and that's awesome. If you understand the fractions, you know. Sorry, I'm talking to myself here. If you understand the fractions, simple fractions like this, that is awesome, good. You don't have to worry about any kind of work. But you don't always receive beautifully simple fractions like this. Sometimes you get something yucky, like, oh, I don't know, 11/23 compared with 7/15. Holy smokes, yuck. I'm not really sure which one's greater than, less than, or maybe they're even equal to. Holy smokes. So what do? How do we compare these gross fractions? Well, firstly, before you have to do any real work, you have to ask yourself, what's the relationship between your numerator and your denominator? So let's just actually look at this. 11 and 23. Well, half of 23, what would that be? Well, I know 11 times 2 would be 22. So that means 11 is a little bit less than what half of 23 would be. Half of 23 would be 11.5. So 11 is a little bit less than half. Okay, that's the relationship here. It's a little less than 1/2. How about over here with 7/15? Well, I know 7 doubled is 14, and half of 15 is 7.5. So, oh, geez, again, 7/15 is a little bit less than 1/2, just like 11/23. Holy smokes. So how do I compare these two? They're both a little bit less than half. Which one's greater, which one's less, or maybe they're equal? Well, here's what we need to do. We need to do something called finding a common denominator. So I'm going to leave this one for now. I'm going to come back to it. I'm going to do something that's going to be a little bit less work, but let's look at, say, 3/5 and 2/3. All right, so these are pretty darn close as well. 3 is a little bit more than half of 5. 2 is a little bit more than half of 3. Okay, so they're both greater than 1/2, but dang, which one's greater, 2/3 or 3/5? Well, the reason these are really hard to compare is because these are unlike fractions. And what I mean by that is they don't have the same denominator. We're not talking about the same pieces of pie or slices of pizza, because these are fifths and these are thirds. They're two different things. They're hard to compare. And we can actually prove that visually. Boom. So here's 2/3, here's 3/5, right? Hard to compare because check it out, like thirds are bigger than fifths, okay? And just because they're bigger doesn't mean necessarily 2/3 is bigger, because we don't have as many thirds. We only have 2/3, we've got 3/5, so that makes them hard to compare. We're comparing two different things. Thirds and fifths are different things. So to make this easier on ourselves, what we're going to do is make these unlike fractions into like fractions. And like fractions have the same denominator. And we would say a common denominator. So I'm just going to go ahead and change my color here. We find a common denominator. And the easiest way to do that is to turn each of these fractions into equivalent fractions that have the same denominator, or common denominator. And here's the quickest, easiest way to do that. I'm going to take 3/5. Now I'm going to multiply both the numerator and the denominator by the other fraction's denominator. So we're timesing both the numerator and denominator by 3. On the other fraction, you probably already guessed it, I'm timesing both the numerator and the denominator by the other fraction's denominator. So that's 5. We're timesing it by 5. All right. Change my color again. All right. So 3/5. Well, 3 times 3 is 9. 5 times 3 is 15. All right. Cool. And keep in mind, 3/5 is equivalent with 9/15. We know this because whenever you times a fraction, both the numerator and denominator by the same thing, it has to be an equivalent fraction. It's the same value. Okay. 2 times 5 is 10. And 3 times 5 is 15. And check it out. We've got a common denominator. Both these fractions are out of 15ths. And now, because we're talking about the same thing, the same size of a pizza slice, it's really easy to compare. So if you're eating pizza, and if you're like me, and you want to eat as much as you possibly can, what would you go for? 10 15ths or 9 15ths? Absolutely. You are going to chow down on 10 15ths of a pizza. That's going to be an awesome day. Okay? And we can say this with absolute certainty because we're talking about the same size of slice. They're both 15ths. And just again, to demonstrate that, check it out. Like let's say I had quarters. Okay, so 1 quarter, is that greater than or less than 2 quarters? Well, I can definitely compare those because they're the same thing, right? Really easy to say that, yeah, 2 quarters is definitely greater than 1 quarter because they have a common denominator. Awesome. So let's go back up to this one. This one's going to be a little harder. That's okay. And I'm saying that because I'm timesing by 23 and timesing by 15. That's okay, though. We'll survive. So again, I don't know. 11 23rds or 7 15ths. I legit don't know which one's greater. So I first need to find a common denominator. So 11 23rds, yeah, you betcha. We're going to times both numerator and denominator by 15. Sorry for my bad printing. Okay. And again, we'll times the other fraction by the other denominator, times it by 23. And if you think I know what 15 times 23 is off the top of my head, I certainly don't. So we're going to have to do some standard algorithm here, and that's okay. That will not kill us. So firstly, I'm going to do 11 times 15. I'll just change my color here quick. Thank you for your patience. 5 times 1 is 5. 5 times 1 is 5. And now I'm going to times by the 1, but I need a placeholder because it's actually a 10. 1 times 1 is 1. 1 times 1 is 1. Add them up. 5 plus nothing is 5. 5 plus 1 is 6. 1 plus nothing is 1. Cool. So when I go 11 times 15, you betcha that's 165. This is going to be an ugly fraction, but that's okay. 23 times 15. Or 15 times 23. Does not matter. That's a commutative property, remember? You can go 15 times 23 or 23 times 15. Doesn't matter. 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus 1 is 4. Now, isn't this kind of cool? That's what I love about math, is that different units are all tied together. I mean, we're talking fractions, but here we are doing multiplication. Kind of cool. Okay, now I'm timesing by the 2, but it's not a 2. It's a 20, so I need a placeholder. 2 times 5 is 10. Carry the 1. 2 times 1 is 2, plus 1 is 3. Add them up. Yep, 300 plus 45 is 345. Cool. So our first fraction, its equivalent version is 165 345ths. Yuck. That is a weird looking fraction. Holy smokes. Okay, so now over here, I don't have to bother wasting my time, 15 times 23, because it's the same thing as over here. So I already know what its denominator is. And that's the whole point, right? We're trying to get a common denominator, right? Common denominator, really cool. So now all I have to worry about is 7 times 23. I'll find some space over here. 23. Thank you for your patience on this, guys. I hope you're still watching. 7 times 3 is 21. Carry the 2. 7 times 2 is 14, plus 2 is 16. Boom. Done. Okay. So now we have a common denominator. Really easy to compare. And now all I have to worry about are the numerators. Which numerator is greater? Boom, this one. So we can say that 165 345ths is greater than 161 345ths. And since I know this, I also know which one of these are greater. 11 23rds. Just keep in mind, these are equivalent with these ones down here. And this is kind of crazy. Look how close they were. They were very, very close. Because you have to think, you split a chocolate bar into 345 parts. Each of those parts are going to be pretty darn tiny. So he was only 4 away from this one. These two fractions are pretty darn close to even, but they're not. 11 23rds is a little bit greater. So Have fun comparing fractions. And remember, the best way to do that is to find a common denominator. And here's one last example. Times each fraction by the other fraction's denominator. And I know that's really messy. I'm trying to go for speed. 1 times 3 is 3. 2 times 3 is 6, of course. 1 times 2 is 2. And 3 times 2 is 6. Check it out. Which one's greater? Easy to compare because they have the same denominator. They have a common denominator. All right, guys, that's enough. Have fun. Good luck. See you next time.